series, and today we are going to talk about Kubernetes RBAC. As we discussed earlier, containers and Kubernetes, why exactly we need it, how we actually use it, and then what are the benefits of using it. So now today we are going to discuss on an RBAC enabled Kubernetes cluster. What exactly an RBAC enabled Kubernetes cluster? RBAC is nothing but role-based access control system. So this are the RBAC is sort of service which are given by various cloud vendors. Some call it as IAM, some call it as RBAC, but at the end of the day, the work is like how do you control each user access with their particular role. Take an example. If I'm a developer, so developer, what sort of role a developer role would be assigned to me on my user ID? Like, take my example. Uh, I have a user object, like email is a user object, or I will have a user object which would be very unique and object which identifies a unique user like me, and it has a GUID. So on top of the GUID, you can actually assign something called as role. Okay, so specifically that the role, uh, a developer role would be assigned to my particular user ID. So that's how they can control like that particular role, which particular that particular role, what it can do on Azure resources and what it cannot do, which particular resources it cannot can access, which it cannot access. So basically the whole Azure portal or AWS portal, they're all controlled by IAM or RBAC access itself. So if you have created that particular subscription, then you will be able to see all of the resources. If you are just a contributor to that particular subscription, you maybe see it, you will be seeing, but you'll not be able to delete those particular resources. You're gonna just contribute. Okay, so that's what is RBAC, and there's a good integration with which this RBAC feature has come up with Kubernetes, and we'll discuss what are exactly the why, how, and what features on top of it. So why we would require an RBAC enabled cluster, in fact, at the first place? It's required because the world is going towards optimizing a solution, or recognizing solutions which are like very underutilized resources. Like till now, what happens, like the Kubernetes cluster, if someone want to spin, they like on Azure or on AWS, you can spin that particular cluster. Okay, so what happens if you spin that spin a AKS cluster or a EKS cluster? So it would occupy a node, and node occupies, or it would be part of a subnet or VNet, because the number of pods which going to run inside that particular node is nothing but, you can say it as a virtual machine. Okay, on top of that, whatever pods or how much pods or containers you're gonna run, so those many the pods, those many like it's equivalent to, like, the number of pods are equivalent to number of IP addresses they're gonna occupy. So what I would say is, like, what happened is the evolution of using this particular number of IPs in particular cluster are sometimes overutilized, or sometimes very underutilized. If even the IPs have been occupied, sometimes the CPU of the node, like if a cluster is created with the node of DS12 and D series VM, but it may not be utilized to the max because the applications are not getting that particular request currently. So that is one thing why exactly why exactly there was a requirement of building a multi-tenant Kubernetes architecture, where you can actually accommodate multiple number of applications or users in a single cluster. Okay, so what you attain, you have a central system to control all of the resources or applications or configurations, even the security or the patches or everything you can update or apply at only one particular central AKS cluster. So those particular operational headaches and management headaches will be loosened up with this particular approach, and this can be enabled, or this can be uh, used or can be implemented with the help of an RBAC enabled cluster, because RBAC would give more granular access with via which you can control users, uh, you know, control users inside your cluster. Good thing about RBAC is like with Kubernetes you have a good integration with Azure Active Directory. So the users who are there in Azure Active Directory can be configured to have access, or you know, who will have access and who will not have access onto this particular cluster. So we will know, we will be doing few of the POCs on top of it, then you will come to know more exactly what I'm talking about. So right now we will be just making a differential points, like what are the benefits. The challenges uh, what was there is like maintaining multiple users. So when the RBAC was not there, users was are supposed to be created inside the Kubernetes or Kubernetes namespaces, and then it was headache of a cluster admin to manage them. So that particular issue is gone because now the users are completely maintained on your Active Directory, and you can give access which particular user can have access to which particular cluster. So that overhead is gone, and the authentication mechanism is all left to AD co-auth authentication, and which has been taken care of between Kubernetes and AKS. That was one great point. And the full control over which operations each user or group can execute. So what happens, like so once you give access to users inside your Kubernetes cluster, till now what used to happen is like either the user will have a full control over the cluster. In that cases, if some mischief happen or someone deletes um, any particular resources, it was hard to find. But now with this particular integration of AD with Kubernetes, it's gonna be easy. And then have full control over each over which the operations each process inside a pod can execute. So there are few of the policies which can be executed on top, and with which we actually can control which particular user can control or request access to which particular pod, or can gain access to which particular pod. And then the last point is the limit the visibility of certain resources of namespaces. So what happens is like with the concept of namespaces, you actually can block users, or you can restrict users from just keeping or giving access to underneath the namespace resource itself. So they won't be having visibility of resources which are out of their particular namespaces, and these all can be achieved, and we'll be discussing in our future classes. And this was why factor for an RBAC enabled cluster. And how we can enable RBAC cluster is there are two ways. The one is a portal way, like portal or the console way, where you just go to Azure or AWS or GCP, or on your local machine you can install by your own, by following few of the articles from the Kubernetes, and then you can spin up your own Kubernetes cluster. Or what you can do is like you can run something as a via console. You can for Azure you can actually run an AZCLI command. So command via command line interface you can actually execute this particular command, which you can see. So what it talks about is AZ is Azure, AKS is Azure Kubernetes Service. Create. It would create a cluster where manage is a resource group, minus n is the name of the cluster, and minus is the location. Minus L is the location, which is the West Europe, or any particular location you choose it. And you have an option of choosing network plugin in Azure. So you can use Azure default plugin or Azure CNI, and then you have a network policy called as Calico. Calico is an open source policy. Uh, Calico is a network policy. So with which what you can do is like you can block traffic from one particular namespace to another particular namespaces, or you can like basically they call it as namespace selector, or you can use something called as pod selectors. There are a lot of concepts which we'll be discussing. And then like you'll be generating SSH keys for this. And then the main thing is like you will be passing something, since we need to do integration with AD or IAM. So we will be having something called as Azure Activity Client App ID, Azure Activity Server App ID, Server App Secret. So these apps can be pre-created, and necessary authentication need to be given before you actually following this particular document. And I'll be pasting how to create this particular AD apps or server apps, the client apps and server apps, using following a simple documentation which is provided by Microsoft. And then you fill all this particular thing, and the AD tenant ID is nothing but your organization directory ID. And you can enable the autoscaler, and you need to keep the minimum count to 1. And pardon, here the maximum count should be 50, so which will be accepted only, 2 will not be accepted. And you can enable RBAC. So this is one factor which would say that your cluster is an RBAC, will be RBAC enabled. And you can skip this generate as the case we mentioned earlier. And then you can choose a load balancer SQ in Azure, like it's a standard load balancer I've chosen. And the node VM size, this is what I'm talking about. Because even if you use something called as VM set type as VM nodes or virtual machine scale sets, you need to mention the virtual machine SKU. So I've taken here a standard DS2V2. Um, so once you have this particular once you run this particular command over the CLI, then you will have an output like this. So the output will be so that you can see the output, what are the different after it creates, it would give you all of this particular details which you have passed upon. And since we didn't enable availability zones, so we will be discussing about availability zones later. You can see auto scaling is true, and max count I've changed to 50, so it's 50. And max pods which we can run is 30. This is because we have not chosen on any on-premise or any VNet or subnet we didn't give. So by default we've chosen an option from Azure CNI, so we have a restrictions of using maximum number of pods in it. And then we will be discussing why exactly is this limitation. As of now, let's proceed. And it says the name of the pool, the node pool. So basically what it does is the cluster would create a dependent resource group, something called as mc underscore uh, mc underscore your resource group underscore your cluster name underscore your particular location. Okay, under that particular location it would spin all of the dependent resources. It's very the AKS is very similar to the another service called as Databricks. So Databricks also creates a dependent resources, and it flourishes all of its resources, like the nodes which it's gonna spin, or the load balancers, or even the public IPs if it would create when you run a service or you set up an ingress. So all of that particular time it would create a dependent resource group, and then it would provision the resources underneath them. You can see a lot of other properties have been added. And you can see the enable RBAC is true, which means that our cluster is an RBAC cluster. And one another and then SQ is basic and tier is free. And you can see the type is Microsoft container service, and they are managed clusters they have. Okay, so in Azure what happens is like so the master node is not chargeable. Only the nodes which you actually run, like the one which have been created with standard DS2V2, we are chargeable on that particular thing. And let me speak about a little on why are we choosing two AD apps or Azure Active Directory apps. So basically Azure Active Directory apps are nothing but sort of service accounts or service principal, which I can say. These are required in order to interact on your behalf without you actually logging in interactively into any of the console or something like that. So why you would require two particular app registrations, or AD app or service principal or service account? So you would require, one is server app registration and another is client app registration. So whenever you run a kubectl command, Okay, so if you run a kubectl command to log into your particular the AKS cluster, so one thing is like it will do an authentication of your user. Since you are using an RBAC cluster, so it will authenticate the logged in user using the server app registration with the Azure Active Directory. For that only you have the server app registration, and then basically the server app registration will have mostly the read access on Azure Active Directory. And then when you run a kubectl command from the client, so the client requests are always, authenticated, or the kubectl command are always authenticated using the client app registrations. So the user authentication will happen over with the server app registration, and the kubectl command authentication will happen over the client app registrations which you are passing during the creation of your app. So yes, I'll be posting up the description of how to create a cluster with pre-create with this particular ADN client and server apps as well. Hope you would like, and we would be having another session afterwards.